determining similarity in triangles. Are these two triangles similar? We have a small triangle, ABC, and a large triangle, ADE, which I've reproduced here. But from this diagram, not counting this one, this diagram, can we determine that they're similar? We're going to rewrite this down here. And notice that BC and DE are parallel. That's what these little triangles mean on two lines. Well, both of the triangles share angle A. And if these two are parallel, then when this line, AE, goes through the two parallel lines, it's just like our old scenario with two parallel lines and a transversal. In a transversal, we know that corresponding angles are congruent. So when we look here, even though we don't have the whole lines out and this whole line out, we can still see that these are corresponding angles. Just like these two. So that means that angle E, angle C correspond and are congruent. If two angles of a triangle are congruent to one another, or are congruent to two angles of another triangle, we know the triangles are congruent by angle. We're going to write our similarity statement. Triangle ABC is similar to triangle ADE. Similarity statement based on the two angles of triangle ABC are congruent to two angles of ADE. What about these two triangles? Are they similar? Well, they both have a right angle. That's one angle. But we don't have a second angle. And we don't know if these are crooked or not. We don't know that these two are parallel. So we'll have to see. This side, DG, would correspond to this side, CF. So the ratio of DG to CF is the ratio of 9 to 18, which if you put it in your calculator, comes out 0.5. If that is the same ratio as these two sides, then we'll have side angle side similarity. So 6 to 12, EG and DF are the ratio of 6 to 12, which also equals 0.5. So we have angles, sides, and sides, or side angle side. Just like when we do congruency, but now instead, the sides are in proportion. We write our similarity statement. Triangle CFD is similar. So CFD goes DGE. It's important to keep the letters in the proper order. Here we have a bow shape. We have two parallel lines, and we have a pair of vertical angles. JK is parallel to HL. And we know that these two angles are congruent, because vertical angles are always congruent. Angle HIL is congruent to angle JIK. I've rewritten the triangles here. This one, then flipped around. Now, we have an angle, but we don't have any sides, so we need another angle. But we can have that when we have parallel lines. These two angles will be congruent. Remember in our old diagram, that Z angles, alternate interior angles, were always congruent. And that's where we have here. This angle and this angle are congruent. Notice that it's this one and that one, not the two top angles. This has been twisted. So angle H and angle K are congruent. Angle I and angle I are congruent. That is enough for angle-angle similarity. When we write our similarity statement, we have to be careful to keep these two in mind and not these two. So our similarity statement is triangle HIL is similar triangle. So HIL. We started with H, that means we have to start with K. KIJ.